Hello guys. So we are going to look on how to switch the career in Big Data Hadoop as a developer, or it can be also a starting step for going into architecture. So how to switch the career in Big Data Hadoop as a developer. My name is Harish Masand. I am Prince 2 and Scrum Master certified and working into IT industry for almost 9 years now and working into Big Data Hadoop as well. So let's see what are the steps and what we should be learning to go into Big Data Hadoop. Starting with agenda. So we are going to see today how did Big Data actually start? What are the different components of Hadoop? Then we'll be seeing how to transition the career into Big Data Hadoop. What are the prerequisites, if any? Then what are the details, like what all things you should study? And finally, if you have any questions to ask. Since it is a recorded session, if you are having any questions, you can either WhatsApp me on this number. This number is present in each and every slide, as well as you can also email me on this ID Hadoop and 4 times 7 at the rate gmail.com. So if you are having any doubts how to learn and so on, you can definitely email on this ID. Okay, so how big data actually started and what is a big data and what is the solution to it. Starting with the definition of big data says that the size of the data sets is so large that a typical database software is unable to capture that data, store the data, manage or analyze the data. In short, the size of data is very high. Your typical software is unable to process the data or even store the data for that case or manage it. So this is called as a definition of big data, or this is called as a big data. Let's see how is the data increasing. As per the research by IDC, it says that unstructured data accounts to 95% of the total data. And according to IDC International Data Corporation, it says that by 2020, the total data will reach to 40 zettabytes or 40,000 exabytes. So you can see actually in the year, let's say in 2010, the data was just around 1000 exabytes. And you can see how much it is increasing. We are currently in year 2018, somewhere over here, and the data is approximately 25,000 exabytes. And by year 2020, it is going to almost double, that is 40,000 exabytes. So we can see over here that the speed by which the data has already increased in this decade, and going forward it will be increasing even more. So this is the way how the data is increasing. It is called as an exponential curve which is increasing. Then let's see why the data actually increased, and let's see what are the companies which are generating more and more data. So if we compare WhatsApp, every minute in the year 2016 around 20 million messages were exchanged. In the year 2017, every minute in WhatsApp, 29 million messages were exchanged. So you can see almost it is increasing by 50%. That is the growth of 50%. Like it was a 20 million, it is becoming 30 million. So it is a very high growth. You can see that in Uber, every minute in 2016, 1,300 rides were taken, and it increased to 3,800 rides in 2017. Similarly, in YouTube, around 2.78 million video views were done every minute. In 2016, it increased to 4.1 million. Google search, around 2.4 million searches, increased to 3.5 million searches. So this is how the data is increasing, and it is a significant increase. It is not a small increase, it is a significant increase in just 1 year, and it is going on increasing exponentially. So this is the reason we are facing big data issues, and big data solutions are so much required at this time. So what is the reason that the data is increasing so much? There are three reasons to it. One is volume, second is velocity, and third is variety. And this is the first thing that anyone who is studying a big data will be learning, what are the three V's of big data. So it is volume, velocity, and variety. Let us try to understand what each of these things mean. Let us start with volume. Let's take an example of a simple image that we take, the photo that we take. Previously, when we were taking using a VGA camera or 1.3 megapixel camera and so on, each photo was around, let's say, around 20 to 40 KB, let's say. But now when we are taking with 10 megapixel, 15 megapixel, 20 megapixel cameras, as well as dual camera, triple camera, and so on in our cell phone, each photo is around 15 to 20 MB. So you can see the same photo if we are taking in olden days, some years back, it was just in KBs, but it has suddenly increased to MBs. So we can see that how the size is increasing, how the volume of data is increasing. Even if you consider an example of a videos, previously it was like HD and so on. Then now it has become 4K and so on. So all these things, what is happening is, if the movie was coming in a 700 MB previously, it will come in 2 or 3 GB now, because of the video resolution, since the resolution has increased. So these things are resulting in increase in data volume. So this is one of the example that results in data volume. Let's say image or video, all these sizes have increased by time, definitely because of the quality as well, but the size is also increasing, resulting in first V, that is volume of the data. Volume of a data that is generated is high. Second thing is velocity. Velocity is speed at which the data is generated. Previously, if you consider the older systems, there were only batch jobs in which the data was coming. Let's say there was a job that was running every night, that was getting a data from one system or another system and so on. Then what happened was, instead of getting the data every night, what we started doing was we started getting data every 1 or 2 hours. Every 1 hour or 2 hours, we will get a data from other system. Then it became near real time. That is, if you perform some transaction or if you are generating some data, it will flow into other systems near real time, maybe within a minute or so. And now everything is real time, even if we are doing a video call, WhatsApp call, and so on, that is resulting in a data being transmitted at a real time. So the velocity or the speed at which the data is generated has also increased. Previously it was only batch, then maybe periodic 1 to 2 hours. Now it is real time, and this is resulting in increase in data velocity. So velocity is speed at which the data is generated has increased. Third is variety. Previously, if you go 1 or 2 decades back, 2 decades back, the data was only in form of table. So table looks something like this, like an Excel. So this is my table. So previously the data was in form of table, like this, my roll number, name, and so on. So it was in the form of table previously. Then came as databases, in which all the tables will be present. Then after databases, now comes a photo, web, and audio. Around the year 2000, there was a big boom of .com. Then now there is lot of social media coming. Since around year 2008, 2009, it has increased a lot. Then videos, unstructured data, mobile is generating lot of data these days. So different variety of data has come. Previously, these data were not present. So different kind of data has started coming. Sensors are coming now. IoT is happening to be a next big thing. And for IoT, Internet of Things, every sensor is going to generate enormous amount of data that is again required for analysis purpose. So this variety of data has also increased. So these are the three V's of big data. Volume. Volume meaning the size of a image video has increased. Velocity is speed at which it is getting generated is increased. Previously it was only batch, periodic, near real time, and now real time. Variety means a different kind of data has started coming. Previously it was only table, then database, photo, web, audio, then comes social, video, unstructured, and mobile. So these are the basically three V's of big data. Nowadays people are going on introducing new and new V's, 4V, 5V, 6V, 7V, and so on. But these are the basic three V's that we need to know. Then let's go ahead. So this is just a salary comparison of what an average person in an IT industry is drawing. So it is being taken from World Economic Forum, and it is a reliable data, and it is an annual package in United States how much a person is earning. So SEO stands for search engine optimization. UX is again a hot field, user experience. So this is a different salary drawn in an IT industry. So if you compare this thing, search engine optimization manager draws 45,000 annually, talent acquisition 63,000, social media manager 40K, user experience 91K, web designer around 53,000 per annum US dollars, solution engineer around 92,000, and on the top is data scientist. Data scientist will be earning around 114,000 per annum. So you can see that how much data in a data industry people are earning currently, and it has been considered with work life balance. It's not that these people are working 24/7 and so on. So considering the work life balance for each of them, the data scientist is earning the maximum. So you will be let's say what we are going through. After that you can be working start working as a data engineer or data scientist, or you can also work as a big data developer and so on. So what we are concluding is a data scientist draws the maximum salary. Let's go ahead. Okay. So what is the solution to big data? We already saw that the data is increasing a lot. It is growing exponentially and so on. So what is the solution to big data? How to process this big data? So until the year 2000, what the companies were doing was they were doing scale up or scale vertically. So what scale up or scale vertically does is, if my small machine is not able to process my data, I will go to big machine. Even if it is not able to process the data, I will go to even bigger machine and so on. So small machine, what do I mean by so small machine is, let's say it is having 2 GB of RAM. So I'll make around 20 GB of RAM over here. I'll make 200 GB of RAM over here and so on. Let's say I was having a single core processor. I'll make a dual core processor over here. I'll make a octa core or a hexa core processor over here. So if I'm increasing the configuration in the same computer, it is called as a scale up or scale vertically. But the problem with this solution was, if I do this way, and if I draw the graph of cost versus performance, performance is over here and cost is over here. The curve looks something like this. Initially it is linear and then it gets saturated. So what does it show is, it shows that if I go on doing the scale up, the cost increases a lot, but I am not getting that much of performance increase. Performance is increasing, but not that significant. So I have to pay a very high cost to get a very less significant increase in performance. You can also consider it with example of a real world. Let's say if I buy a 256 GB of SSD, it will cost me around 200 Sing dollars and around 10,000 INR. And if I go for 1 GB, 1 TB, 1 terabyte of SSD, it won't be 4 times, it will be even more than that. Let's say around 800 to 900 SSD, 800 to 900 Sing dollars. So even more than that, in fact, around 1000 Sing dollars and so on. So if I go on increasing the capacity, the cost increases a lot as compared to what is the gain in the capacity. So what we are saying over here is, if we go with this solution of doing a scale up or scale vertically, the cost increases a lot, but I don't get that much in performance. So what is the solution? If this doesn't work, then the solution is, if I'm having a bullock cart and if I'm having a bullock cart and instead of one bull that is pulling it, instead of growing that bull big and big, I'll put more bulls into picture. Let's say I'll put a two bulls to or to pull this bullock carts. Or else I will be putting, instead of growing that particular one ox, I'll be putting two ox over here. So this solution was given by a grasshopper, which who was an engineer, and it says that instead of growing a one ox, what we can do is we can use more than one ox instead of making that single ox big and big. So we can use, instead of a single ox, we can use two ox or three ox or four ox. So similarly, if we implement the same solution over here, it says that instead of increasing or growing that single computer big and big, what I will do is, instead of making this computer big, I will replace it by two small computers, replace it by four small computers, and so on. Let's see in the next slide. So you can see that over here, a single computer, if it is not able to solve the problem, we are replacing it by two computers or two machines and connecting these two machines in parallel. Similarly, connect to three machine and connect this in parallel. Three machine, connect this in parallel. So this is called as a scale out or scale horizontally, wherein instead of a single machine, I'm putting two machines in parallel and again putting three machines in parallel and so on. So what do we achieve over here is, previously if we draw cost versus performance for the previous case of scale up, as we saw in the previous slide, the curve was something like this. The cost is increasing very much, but I'm not getting that much of performance. But if I draw the cost versus performance over here for scale out, I'm using the same configuration. So the cost and performance increases linearly. So if the cost is increasing, the performance is also increasing linearly. So this is the benefit of doing scale out or scale horizontally. We are going forward. If you are having any doubts, feel free to get in touch on this number on WhatsApp. Okay, let's go to solution to big data. So in case of big data, how we do is, instead of putting a more and more big PCs, what we are doing is we are connecting multiple computers in parallel. All these computers that are connected in parallel, these are connected in slaves and called as a nodes. And there will be one master that will be controlling each of them. So there is a master and there is also a secondary master, so that if master fails, then the secondary master can take over and uh, do all the resource allocation and so on. So this is how the Hadoop actually looks like, or a solution to big data actually looks like. Multiple computers connected in parallel that are called slaves or nodes, and it is controlled by master. Okay, going further, since we saw already that there are multiple computers connected in parallel, it is possible that sometimes this computer fails. Sometimes this computer fails because these computers that are connected in big data Hadoop are nothing but the normal computers that we use at home or offices and so on. So these are not high-end configuration. This is the normal computers that we are using, and the chance of failure is again high. So it is possible that some of the computers may fail. This computer may fail, or this computer may fail, and so on. So to handle this failure, if this computer fails, all the data in this computer is lost. If this computer fails, all the data in this computer is lost. So to handle the failure, what we do over here is, to handle the failure, we use something called as a replication. So what replication means is, the entire data will be stored at least at three places. The entire data will be stored at least at three places. Each data, whatever is the data will be stored at least three places, and it is controlled by a replication factor. Of course, replication factor is configurable. You can prefer to configure it to 2, or you can prefer to configure it to 4, and so on. So replication factor is 3, that is, each of the data will be stored in 3 computers. So what will happen because of this is, let's go back to the previous slide again. What will happen because of this is, let's say if this computer fails, the same data is also present in these two computers, because the same data is present at 3 computers. So the same data is also present over here. So even if this data fails, we still have a data over here. So there is no data loss. And also what this master will do is, since one copy is lost, it will also replicate in another PC automatically. So again, there is a third copy. So even if this one is lost, the data is present here and here, and it will replicate over here. Let's say this is also lost, so still the data is present here and here, and so on. So to handle this failure of computers or the machines that are connected in parallel, what do we do is, we use a replication factor. And replication factor means that same data will be stored at least three places if the replication factor is configured to 3. So this is about a replication. The second thing is partition. Since my entire file is very big, we are working in a big data. Since my entire file is very big, I cannot afford to store the same entire file into a single machine. It may be a case that sometimes my file is so big that I can't even store in a single machine, because that machine is already getting full. So what we do over here is, in Hadoop, there is something called as a partitioning. So let's say this is my data, this is my entire data of, let's say, 300 MB. What it do is, it divides into 128 MB block, 128 MB, 128 MB, and remaining is 44 MB. And it will store this in computer number 1, computer number 2, and computer number 3. So this is called as a partitioning, wherein the data is broken into small parts and stored separately. So Hadoop cluster uses a partitioning. This is the example of partitioning. Hadoop cluster also uses a replication, so that even if the single computer is failing, the same data is present in other computer. So Hadoop uses partitioning as well as replication. So it will look something like this. Each of the data is replicated at least 3 times, 1, 2, and 3. And it is also broken into small parts while storing. So 128 MB, and again 128 MB, and again 44 MB. So this is how my entire data is stored. So this is about partitioning and replication. Let's go ahead. Let's take an example of how the big data is used in an insurance industry. It is used in all kinds of industry: insurance industry, banking industry, transport, like different transport operators like Grab, Uber, and so on, uses the big data solutioning a lot. It is used in a e-commerce, it is used as a weblog analysis, it is used in each and every domain where the data is present. So let's take an example of a case study of use of big data in insurance. It is used for risk assessment, that is, by having the previous claims data, we can analyze that which claim or which place is having high risk. Let's say we can identify that a particular area, there is a high chance of a car theft. So this kind of risk analysis can be done using the previous data that is available. Can also do a cross selling, like if you take an example of Netflix, how Netflix does a cross selling like thing is, let's say it says that because you watched movie XYZ, you will also like to watch the movie ABC, and so on. So this is called as a cross selling, that is suggesting a different product to the customer. So what they do is they study the behavior of other similar customers. So if the other similar customer has bought the policy A and also later bought a policy B, so they will analyze this thing that most of the people who buy a policy A also buys policy B. So what they will do is, let's say in future if someone buys policy A, they will also try to sell policy B to them, and it will be mostly successful. Of course, there is no 100% guarantee to it, but the cross selling most of the time it works if we are doing a proper cross selling by analyzing the previous data. It can also be used for a fraud detection, like we can match the claims coming with the previous all claims having fraud. If the behavior matches, let's say if a claims comes from a person A who is admitted to hospital XYZ, and let's say hospital XYZ has a history of bad claims, looking at the previous data, history of fake claims. So what the system will do is it will mark that particular claim as a possible fraud claim, so that it can be looked by a claim officer more properly. The big data can also be used to improve the customer experience. So it can be used to improve the customer experience, like by checking the behavior data, how the user is using the particular app of insurance if it is installed in his PC, how he is browsing through things, what are the reviews that he is giving over the website, and so on. So it can also be used for enhancing the customer experience. So these are the use cases for big data.